Continuing on with our graphing segment, today we're working on parallel and perpendicular lines and graphing inequalities. So take a minute to look at what you notice here between these three lines. You can pause the video. First thing you'll probably notice is they are what we call parallel, means they never intersect. We can get a little more precise if we look algebraically at each of these. We will see they each have a slope of 2/3, 2/3, and 2/3. So they all have the same slope. The other thing that hopefully you notice is that they also have different y-intercepts. If they have the same y-intercept and the same slope, they would be the same lines. So for parallel lines, they need the same slope but different y-intercepts. You'll notice here it's the same thing, but instead of a positive slope, we have negative slopes. So we can start with any 2 points, and you just count from the left point to the right point, whatever it may be. We could start here and go here, down 3 to the right 2. These all have the same slope. Here, take a minute, pause, see what you notice. First thing, and you might have forgotten the term, at the start of the lesson, we see that these lines intersect, but it's a little more specific than just any intersection. They intersect at a right angle. So these two lines are what we call perpendicular. Perpendicular means two lines that intersect at a right angle or 90 degrees. That is not how you spell perpendicular. Then if we check the slopes, we'll see that the red line has a slope of -3/2. So we've got a slope of -3/2. The blue line has a slope of up to over 3, 2/3. And if you notice, those have similar parts, but they're also kind of different. So for a perpendicular line, we say the slopes are opposite reciprocals or negative reciprocals. Opposite and negative means the same thing. Where the sign of the reciprocals are opposite, so this is a negative, this is a positive, and if there's no plus there, we just assume it's positive. Reciprocal means we take the numbers and we flip them. So 3/2 flips to 2/3 and vice versa. So if you have two slopes that are opposite reciprocals, that means one is positive, one is negative, and their numbers are flipped, then you have perpendicular lines. In words, so two lines that are parallel have the same slope and different intercepts. That's the important part there, same slope, different intercepts. If two lines are perpendicular, the slope of one is the negative reciprocal of the other. Those would be important to have in your notes. I will often say opposite reciprocal. That's just how I'm used to saying it. It's the same thing as negative reciprocal. On the reciprocal part, it's a fun word. If you have 4, then the opposite reciprocal would be -1/4. Because 4 is the same as 4/1. So you flip it and you get -1/4. If you had a slope of 1/6, -1/6, let's say, the opposite reciprocal would be +6. Okay, those ones are kind of funky, but the rest are pretty self-explanatory. So go ahead, pause the video, and do these practice problems. So for the first one, which is parallel to 2x plus 5, looks like B will be, because you divide by 2, you get y equals 2x plus 3/2. They have the same slope, and they have different y-intercepts. So B would be our answer. For 2, I'll do that on the next slide. Number 3, I'll do that on the next slide. Well, I guess we can do it now. So that's going to be y equals 2x plus b. We're going to plug 1 and -1 in. So -1 equals 2 times 1 plus b. -1 equals 2 plus b. Subtract 2 from both sides. b equals -3. So for number 3, our equation would be y equals 2x minus 3. For perpendicular, remember we want opposite reciprocal. So if this is positive here, positive 1/2, we need a negative, and it needs to be different, or it needs to be flipped. So B would be your answer yet again. But 5 I'll do next slide, and then 6 I'll do next slide. Just kind of, I'm running out of space. So this was number 2, I think. We've got a point at 1, -1. Should be here, and a slope of 2. So we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2. We just keep doing that. If you have a ruler, you don't have to keep doing that. For me, I kind of need to get to the top here to then be able to get a nice straight line. When you graph, your line needs to cover the whole window, and you put arrows at the end. That's what a correct graph looks like. We already did the equation for this one, so I'll skip that. Here for perpendicular, we know we want to go through 0, 0, and we want it to be perpendicular, so 1/2 is the same as -2. So we go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Close enough. I can get a pretty good idea from here. There would be our line. Because our original line is at +4, and up 1 over 2, up 1 over 2. Our original line here is going to be something like that. And those are perpendicular to each other. The equation for the black line, we could do some fancy stuff, but we know what the y-intercept is at 0, so it's just y equals -2x would be the answer for number 5. When we're graphing inequalities, we're going to be looking at more than just one answer or one line. So normally we've been doing y equals 2x minus 3. Now we've got all these different inequalities. Y is greater than 2x minus 3. Y is less than 2x minus 3. Y is greater than or equal to. Remember, this little line below the inequality means equal to 2x minus 3. Y is less than or equal to 2x minus 3. So we're going to consider y is greater than 2x minus 3. What we're going to do here is we're going to graph that line. So 2x minus 3, start there, we go up 2 over 1, and then we graph our line. Just like that. And now we're going to pick 3 points. We're going to pick one point that's above the line, so something like this. We're going to pick one point that's on the line, anywhere on the line, and then pick one point that's below the line. So for the black, that is at 1, 3. For the red, we're at 1, -1, and blue, we're at 1, -4. If we plug the black into this inequality, we've got 3 is greater than 2 times 1 minus 3, which would be 3 is greater than -1, which would be correct. So that point is a solution. We then plug in 1, -1. So -1 is greater than 2, 1 minus 3. We get -1 is greater than -1. That would be incorrect because they're the same. -1's not greater than the other one. And then lastly, we get -4 is greater than 2, 1 minus 3. So -4 is greater than -1 yet again. That would be incorrect. So because this is our this one's correct, what we're going to do is two things here. First, we're going to change our line from solid to dotted. So I kind of got to do it funky here because this just messed up on me. So dotted means you can't be on the line. Solid means you can be on the line. And then we're going to shade everything above the line because any of these answers up here are solutions. So that is how you graph an inequality. So here are the steps. So you graph the line first. If it's a greater than or less than, then it's a dotted line. If it's greater than or equal to or less than or equal to, it's a solid line. You pick 2 points. I know I showed 3, but you only need to pick 2 points because you should have an idea if it's solid or not already. One on each side of the line, wherever the point makes the inequality true, shade in that side of the line. And then one thing to remember is when you multiply both sides by a negative, you have to flip the inequality. So if we had like negative 2y is greater than 4x, to graph this, we need to get y by itself. So we divide both sides by negative 2. So then we would have y is less than, notice how this switched from that because we divided by negative 2, negative 2x. Same thing if you multiply by a negative, you flip the inequality. Okay, last couple ones for you to work on. All right, so for that first one, we've got y is less than or equal to x minus 1. And less than means all of our y values need to be less than the line. So I just pick a point and it needs to be everything below it. So that would be your graph. For the second one, it's a lot of undoing. We need to fix it first. So we're going to divide by that negative 1 here. So we got y is greater than 2x plus 1. So up 2 over 1. Now it's greater than, not greater than or equal to. So we're going to need to dot this. And then it's greater than, so we want everything above the line. For the third one, we need to add 9 to both sides. We've got 3y minus 9 is greater than or equal to x minus 3. We add 9 to both sides. 3y is greater than or equal to x plus 6. Divide by 3. Y is greater than or equal to 1/3 x plus 2. So we're at that plus 2 again. Here, it's 1/3, so up 1 over 3. Up 1 over 3, up 1 over 3. It's a solid line, and then it's everything greater than. So it's all this. Then the last one, we've got negative 2y is greater than or equal to 3x plus 6. Divide by negative 2 everywhere. So y is less than or equal to, we flip it because we divide by a negative. Negative 3 halves x minus 3. Negative 3 halves means we go down 3 to the right 2. Down 3 to the right 2. And then we can make our line. It's greater than or equal to, so it's a solid line. And then it's y is less than, so that means everything less than, so it's all down here.